Welcome to the session on Polyglot data management of the lecture NoSQL databases. This lecture is based on my book Advanced Data Management, where you can find more information on the topics. Today we will cover several architectures for Polyglot data management. First of all, in an application, the data management layer has to handle contradictory requirements. Several applications might have different access patterns. For example, one application might have write-heavy workloads, whereas the other one might have more read-heavy workloads. Regarding the data model, the applications might have to process data with very different structures. Access methods might also differ. A web application might prefer HTTP-based REST access. Other applications might prefer access by a programming language or by a query language. Now, instead of choosing just a single database system that only meets one or two requirements, we will look at several options for architectures that can satisfy several of these requirements. The first option is polyglot persistence. With the idea of polyglot persistence, you can choose as many databases as you need to satisfy all requirements of your applications. In order to offer unified access to all databases, an integration layer should be introduced. Tasks of the integration layer include to decompose queries into subqueries, to redirect queries to the appropriate databases, and finally to recombine the results from the databases into one global result. An open source product offering polyglot persistence is Apache Drill, which was inspired by Google's Dremel system. To summarize, polyglot persistence tries to accommodate several users with different requirements. The integration layer offers several access methods to different applications and users. Several kinds of databases and data stores can be connected to the integration layer. The integration layer then unifies access to these different systems. As a second option for polyglot data management, we will look at the Lambda Architecture. The Lambda Architecture addresses real-time requirements for processing streaming data. The Lambda Architecture combines batch processing for historical data with stream processing for more recent data. The so-called speed layer collects the most recent data and delivers them in so-called real-time views. Lastly, the so-called serving layer offers indexes on the batch layer. These indexes make the master dataset more efficiently accessible to user queries. Queries are then answered by merging data from the batch views or from the indexes offered in the serving layer and the data from the real-time views. An example of an open source system is Apache Druid that offers streaming data in real-time nodes and batch data in so-called historical nodes. To summarize, the Lambda architecture processes a stream of data. It takes some time to append new data to the master dataset and pre-process indexes for them. That is why all data are also collected in the speed layer. After new data have been merged into the master dataset, they can be removed from the speed layer. As a last option for polyglot data management, we will look at multimodel databases. They consist of a single data store, but they provide access to the data by using different APIs. That is, they support different data models in the same database. To do so, the database can either process the different data models directly inside the database engine, or it offers layers on top of a single model engine. Two open source competitors are OrientDB and DurangoDB. Both offer different APIs as well as a SQLite query language. As an example for a multimodal database, we have here a key-value store with which write-heavy transactions or REST-based access can be supported. Moreover, the database offers a graph layer that can process graph-structured data. This was the session on polyglot data management. Thank you for listening.